Backpropagation in neural networks. Backpropagation in neural network is defined as a mathematical process that allows machines to learn from their mistakes. What is backpropagation? When you make a mistake on a test, you can go back and figure out where you went wrong. Backpropagation does the same thing for computers. It uses chain rule to do so. It automatically adjusts the network's internal parameters, which helps the network make better predictions the next time. The learning problem. Imagine you're trying to teach a computer to recognize cats in photos. Neural networks start completely random, like a newborn baby who knows nothing. Initially, the network will guess randomly where an image contains a cat or not. If we had a small network, maybe we could manually adjust it. But modern networks have millions or billions of parameters. Backpropagation automates this tuning process. Now we discuss the neural network architecture. It has an input layer where data enters. The hidden layers act like the thinking layers of the network. The output layer gives us the final answer. The weights described as the strength of connection between neurons, and the biases show the personal preferences each neuron has. They help in fine-tuning the decision. The activation functions dictate whether the neuron should be excited or not based on the input it receives. Now we discuss the forward propagation process, which shows the data flow through the network. This is called as the forward pass. The data enters the input layer. Each connection multiplies the input by its weight, and then we add all these products together plus a bias. We apply an activation function. The output then becomes the input for the next layer. This continues until we reach the final layer and we get our prediction. Once we have a prediction, we can compare it to the correct answer and see how wrong we were. Loss calculation is done with the help of a loss function. Here different type of loss functions are shown, but the goal of a loss function remains the same. How is to minimize the loss. The smaller the loss is, the better our network is performing. Now the backward pass. This process is how we actually improve the network. The chain rule helps us trace back through the network. For each weight, we calculate how much changing it would reduce the error. The delta represents the error signal flowing backwards through each layer. The gradient tells us both the direction and the magnitude to adjust each weight. Finally, we update each weight by a small amount in the direction that reduces the error. Here a numerical example is shown. We start with some input values and initial random weights. Then in the forward pass process, we calculate step by step and get a prediction of 0.667 when the correct answer was 0.9. Our error loss is 0.2027, which is not terrible, but we can do better. The backward pass process helps us calculate how much each weight contributed to this error. We find that by increasing the weight 3 by 0.003 would help us reduce the error. After updating the weights, our next prediction would be closer to 0.9.